financial math, and more compound interest. Remember, compound interest is money that is earned or paid on the principal and the interest. The accumulated amount is always the same. It's the sum of the money invested and the money earned. But what we really want to know is, how does compound interest relate to our current knowledge of math? In the video lesson you watched last night, you saw the example of Susie's grandparents. And Susie's grandparents would like to see her have a car in 10 years to use in university. When she was born, they invested $600 at 7% per annum, compounded semi-annually. Now that's different than what we did yesterday in class, because we only compounded interest annually. So if we accumulated it semi-annually, it means that twice a year we're earning interest. So we need to take that 7% that we're earning overall in the year, and we have to share it between the two compounding periods. So if we were going to use the Inspires, which is what I had planned, but obviously you're not using them today, we would have ended up entering all the same information as we did yesterday, except for interest, we would have changed that to 0.035 times B1. And everything else in the table on the calculator would have remained the same, and we still would have had 20 rows of data, because we were compounding our interest twice a year for 10 years. And you'll notice we get a very different accumulated amount, because we're only collecting or saving the money for half the time. When we did the graph of this, we saw exactly the same thing. We got an exponential function. Okay, it was increasing by a constant ratio. And when we do the regression, we end up with a screen like this, and we see that the regression match is almost perfect. It shows up as 0.99999. It actually is perfect because of the nature of what we're doing. And if we state the equation, oh, we already talked about that. If we state the equation that models the data, we end up with 600 times 1.035 to the exponent n. And we got those values from the regression. So right here, the a value in the equation is 600, and the base is 1.05 in the equation. Now, what is the $600? Let's go back again. Where do we see $600? Right here. That's how much they invested. The base of the power was 1.035, and we know we always start with 1 plus something if we're increasing, and it's 1 plus, well, yesterday we used R, which is 7%, but we only added 0.035. So what did we do? We divided R by 2. So we did 1 plus R over 2. Sorry guys, it takes a minute to scroll through. And we changed our variable, or I changed it to be n, because n is the number of compounding periods. Remember, we're not determining the number of years now, we're determining the number of times we calculated interest. We did it 20 times because it's twice a year for 10 years. Okay. So we're going to modify the formula we had yesterday so that we now have 1 plus I, which is the interest rate per compounding period, and we have an n, which is the number of compounding periods. So we'll have to do a bit of extra calculation in order to calculate compound interest if your interest is not compounded annually. We have lots of things to remember. I was just equal to R if it was annual, and M was time. If it was twice a year, we multiplied the number of years by 2, and we divided our interest rate by 2 to determine the I value going in the equation. Quarterly means 4 times a year, so the 2 and semi-annually in both cases changes to a 4. Monthly is 12 times a year, so we're switching to a 12. Weekly is 52 times a year. Bi-weekly is 26 times a year because it means every 2 weeks. And daily is 365 days in a year, so everything is either divided by 365 for I or multiplied by 365 for N. What you're going to need to practice with over the next couple days in class is how do I do this on the calculator, and it's not really stressful, but I'm going to show you here and we'll get the calculators out again in class tomorrow to work on it. So if I want to determine the accumulated amount of an investment of $2,300 after 4 years at a rate of 6% per annum compounded annually. Okay, so let's highlight, we're looking for the accumulated amount, we're investing $2,300 after 4 years, 6% compounded annually. The word compounded is key because it tells me to go to this A equals P times 1 plus I to the N formula. Now, let's go to the equation. 2,300 is principal, 4 is T, and the 6% is R. So we need to be very careful what we're plugging in. So my principal is 2,300. My interest rate is 0.06 because of course I have to work in percents. And I is going to be 0.06, and I'm just dividing by 1 because it's annually. T is 4, and because it's annual, N is also 4. So A is equal to 2,300 times 1.06 to the 4. And when I get my handy dandy calculator out, that becomes $2,913.57. Remember, this is money. It should end in the pennies column. And also, I didn't do it here, but I should have. Start by writing out the basic equation because you aren't going to be given that equation on a test. That is an equation you should know. And you should be able to derive because we know compound interest increases exponentially, and our knowledge of exponentials and our knowledge of exponential equations should allow us to create that even if we forget this general formula. Again, we're going to skip over the next couple slides because it's calculator based. This one here is quarterly. P is going to be the same. It's always good though to keep writing out your variables. I is 0.06. It's quarterly, so I'm dividing by 4. And N is 4 times a year for 4 years. Again, start with our base equation. And I'll have 1.015 to the 16. And when I get my handy dandy calculator, I see that the answer is 2918.67. And you should be noticing something that's happening. The more often I calculate my interest, the more money I end up with, which makes sense because we are in fact earning interest on our interest. Last one, monthly. What's going to change here now? I is 0.06 divided by 12, so 0.005. N is 4 years, 12 times a year. So now we substitute all of that in our handy dandy formula and we get out our handy dandy calculators. And you end up with $2,922.13. And you'll notice that I've written sentence answers for everything. You'll also notice my dots are above my equal sign when I do my calculation, but I don't need to write the word approximately in my sentence answer because that's exactly what they're giving me because they're not giving me part pennies at the bank. And again, that's the calculator screen. Before class tomorrow, exercise 3, pages 9 to 10.